Hi everybody, my name is Tracy Lamb from Quantum AI, based in the United States. However, I'm an Aussie and it is a real privilege to be able to present to World of Drones in Brisbane today. I'm currently in Canada at Drone Enable presenting, and I'm sorry I can't be there to interact with you all in person. This is a turbo presentation on the future of safety, focusing on my recent research and work into safety and human factors in safety management systems, focused on advanced air mobility drones and also vertiports. I'd like to share my screen with you now. And let's get started on the presentation. So, as I said, future of safety. Safety is changing. We build upon our traditional ways of managing safety and risk management in aviation, but due to the complexity of automation and technology, safety and how we measure it and how we manage it has to evolve. So this presentation is a very fast one. And we're really looking at the fact that aviation has been the original testbed for advances in automation, highly automated systems, such as we see flight management computers that were developed in the 1960s, right through to some of the more recent advent of very efficient automated systems. A little bit about my background. Obviously, I am from aviation. I spent a long time as a commercial pilot doing all sorts of kind of flying, including I spent a lot of time as a flight instructor. I was also an airline pilot, corporate jet pilot. Eventually left the cockpit of regular aviation to get into unmanned aircraft systems because what fascinated me was initially I thought you take the humans out of flying the aircraft and you should have a lot less human factors, a lot less error, a lot less mistakes. But in actual fact, you have up to 300 times more of human error, misjudgment, and human interaction contributing to mishaps than you do in regular aviation. I've devoted my research to that particular topic over the last several years, and I have currently 18 academically published research projects, and 10 of those I have been the lead project investigator. I'm pretty excited to continue my research as I finish my PhD towards the end of this year, first quarter of next year. And obviously my area of my dissertation is in safety and safety systems, focusing on urban air mobility and vertiports, but more on that next year. My current research, I participate and track a lot of the R&D that's going on in the NASA collaborative workshops and the NARI, which is the NASA Aeronautics Research Institute. And as you can see, fantastic place to get the latest information if you're looking for it. It's all publicly available. But as you can see, NASA's working groups have identified 5 main pillars to aviation and operational safety concerns regarding implementation of UAM, and also 8 barriers. But a more recent paper by Medonka et al. 2022 showed that there are actually over 450 considerations when it comes to UAM implementation, and they've identified 8 groupings. Well, why is that important? Well, that's going to help safety practitioners in the future develop and refine their safety management systems for managing vertiports and managing their urban air mobility safety management systems. And safety should be your safety management system in many countries that contract to ICAO or that are a member of the ICAO conglomerate of contracting states, are regulatory required to implement some kind of safety management system, but some are not. Some countries, depending upon the level, stipulate that the safety management system is a voluntary system that is commensurate with the size and complexity of the operation. Well, when you consider urban air mobility, size and complexity really is going to be at the heart of decision making, because urban air mobility is a complex ecosystem, and it is going to rely a lot on emergent technologies, AI, machine learning. And a question for us researchers is the human going to be over the loop, on the loop, out of the loop? or completely out of the decision-making process? And the answer is yes, to some extent, to each of those areas. So as you can already see, it is a very complex ecosystem to try to figure out how are you going to build your safety management system. Again, on the NASA portal, you can find information about vertiports. The FAA, Federal Aviation Administration here in the United States, released an engineering brief on the 21st of September this year. Also, the Advanced Aviation Advisory Committee met and released their ebook, and you can get that free off the FAA website as well. And all of these areas point to the fact that formal safety management systems are going to be required to some extent by regulations and by standards. But caveat is, because this is an emerging industry, there is still a lot of work to be done in this space. And particularly in the case of the vertiport design standards that the FAA engineering brief put forward, they tell us that they're actually not performance-based standards at the moment. They primarily relate to the infrastructure and the physical being and look and requirements of the vertiport rather than safety performance-based standards. So there's a lot of this information yet to be discovered, yet to be put out to the community. And that's one of the key areas of my research and what really excites me. So what are we going to look at for operational safety performance, key performance indicators or KPIs? You know, what type of data do you need to collect? Where are you going to get this data from? How are you going to analyze it? Do you have the workforce in-house to analyze this data for meaningful outcomes? Because at the end of the day, what does the data mean? And some of the examples of what the key performance indicators might be that you want to look at is human operators' task and performance, their workload considerations, their workflow considerations, tarmac logistics and passenger movement and passenger safety, competency-based training for your workforce and your workforce development, hazard reporting culture, that's a whole other presentation. Your pilot and operator qualifications are obviously another thing to consider. But also there's a lot of work going on at the moment by the providers of UAM services or the PSUs and also supplemental data service providers. Their quality and consistency of data that feeds directly into your safety system, not only if you're a vertiport operator, but if you are an original equipment manufacturer or an operator of these aircraft. Food for thought for all of you in the audience today. Have a look at this graph. You can see that this graph has a lot of ups and downs. It's actually the Acro Air accident graph, and it's a very old graph from 1918 when aircraft started to be flown more readily, right through to the early to mid 2000s. Now, this graph has not been updated in a very long time, but it's one of the things I like to show, and I did present this when I used to be an instructor at RMIT University in Melbourne. Have a look at this graph. You start there in the 1920s, and the total accident rate was kind of going up and up steadily. It peaked in 1940s because of World War II. So this does include war and sabotage. Then, understandably, after the World War II, the accident rate plummeted down until about 1960. And then you can see that sharply, even though aircraft were maintained better, they transitioned from turboprops to jets, which meant less mechanical failure, the accident rate sharply increased in the late 1960s to 70. And why? And my students are often very surprised to hear that it coincides to the advent of the integrated autopilot and flight management computer, the first integration of highly automated and complex systems. Interesting fact. Then if you have a look into the 1980s, you have it peak until you see the advent of human factors and crew resource management training. Then, so effectively, they started training the pilots to help build their cognitive models to to support situational awareness. And this worked because you can see from the 1980s, the accident rate decreased again. And then interestingly enough, it slowly started to creep up again. This is often referred to as the era of pilot error, or the blame the pilot era. And a lot of professors will actually say that it was a time where they discovered that it's not just up to the pilots, it's actually a team effort. And that was the advent of organizational safety and policy and procedures and regulations. So I love this chart. You can see then the accident rate then decreases again because the era of organizational safety evolved. Safety culture and safety management systems were introduced. We continued to see a reduction of accidents, an increase in safety and productivity, and an increase in automation. So once we know how to handle the automation, automation works for us and makes us safer. But you have to know, how are the humans integrating in this system? And here we are today, a new era where automation and technology are at the forefront and going to make the industry even safer and even more efficient if we know how to manage it properly. So ICAO knows this. If you go onto the ICAO website, this is directly from the ICAO Safety Management Manual, and it shows those eras that I just discussed, with a focus on the fact that this new total system era of aviation safety really does rely on the integration of the human behavior, policy, procedures, and the systems. And these systems are cyclic. They're in a cyclic, continual loop of improvement. So I could talk about my favorite subject all day long. Thank you for listening to me about my passion for aviation safety, risk reduction, resilience, and safety management systems. And if you have any further questions, please feel free to reach out to me at tlam@quantum-ai.global, and I will see you all around in aviation. Thank you very much. I'll stop my sharing and I shall end this recording. Thank you.